implemented by the AEOA partnership. And I'd like to take this opportunity to thank all partners who have put a lot of work. Facilitated by SARI, who are the organization that I work for. We are the AEOA lead and provide the secretariat for the Alliance. The symposium has been organized and implemented by the AEOA partnership. And I'd like to take this opportunity to thank all partners who have put a lot of work into making this event happen. Particular thanks go to Bree from SARI, who has done the majority of the logistical organizing. Before introducing AEOA, I just wanted to give you a brief introduction to SARI for those of you who don't know about our organization. SARI is a charity registered with the Charities Commission of England and Wales, operating from its principal offices in the Falkland Islands, with offices also in the UK and staff in the Turks and Caicos Islands and in St. Helena. Our vision is to deliver world-class environmental research from the Falkland Islands that informs the effective stewardship of our planet. Our mission, which is also on your screen, is to advance environmental understanding in the territories and countries in which we operate through partnerships, research institutes, and centers to deliver research excellence and innovative science leadership. We use our unique expertise to share, communicate, and apply our skills and findings to find innovative solutions to common environmental challenges. If you want to find more about us, then I have the web link there, or you can follow us on Twitter at @SARI_FI. In implementing our vision, we work across the world, and this map gives you a flavor of where our projects are focused. We have a lot of activity in the Falklands, of course, where our research covers both the marine and terrestrial environments, where Earth observation plays a key role in much of what we do. And you will hear from our Dr. Steffi Carter shortly on how we have used Earth observation to map the soils of the Falkland Islands. We also work in the Caribbean, the South Atlantic, Southern Africa, and of course, South America, where we build strong partnerships and alliances and are very pleased to be part of the development of this particular alliance with our South American colleagues. So now a brief introduction into AEOA. You can pronounce it as you wish, pronounce the acronym as you so wish, but it stands for the Austral Earth Observation Alliance. So we created this alliance to provide innovative solutions for environmental sustainability, with the goal to create long-term and sustainable Earth observation, a long-term sustainable Earth observation alliance that develops remote sensing techniques and promotes their application in the science, industry, and society through a network of collaborators. The vision is to become the platform to utilize Earth observation through a tailored network of countries and territories in the South Atlantic and South American region, sometimes referred to as the Southern Cone and beyond, to support and facilitate government bodies, non-governmental organizations, researchers, and the private sector to make informed decisions in their use of Earth observation data, enabling them to develop action plans and strategies for the sustainable development of the region. To bring together scientists with a background on geospatial science, build working collaborations among research institutes, focus on topics that are relevant in the users within the South American and South Atlantic region, and organize knowledge transfer across countries and territories. To develop learning facilities, capacity building, and making data and tools open and available to a much wider public, and to create a toolbox of solutions for common issues. This feeds through to our objectives, which are how to discover how Earth observation in combination with current activities and in situ data availability can make a positive contribution to the region. to build capacity by enhancing the skills and capabilities of network members, empowering them to successfully deploy and use Earth observation technologies. And finally, to develop out-of-region partnerships to bring in additional capability through capacity, skills transfer, and funding. So a lofty set of aims, objectives, and goals. But what you'll gather from those are that AEOA is all about partners and partnership working. The logos here represent the core partners of the current AEOA who have all signed a memorandum of understanding to formalize the partnership. You will see that in addition to SARI, we have the UK government's Joint Nature Conservation Committee, JNCC, who were instrumental in developing the AEOA concept through a workshop at the University of Magallanes that they funded in 2018 and have continued to proactively develop AEOA. We'll hear from JNCC's Dr. Guo Jones on some of the Earth observation work in the region today. The University of Magallanes in Chile, SARI's nearest academic neighbor, is also an AEOA core partner who hosted the 2018 workshop and continue to work closely with AEOA partners. And we'll hear from Dr. Sergio Radic from UMIG on some collaborative research today as well. University of Chile are an AEOA partner, and the photos here show researchers from University of Chile on an exchange visit to the Falkland Islands in 2019 as part of the AEOA partnership. University of Santo Tomas in Chile is another AEOA core partner, and you will hear from Dr. Fabio Labra today on some of the exciting Earth observation research that is being undertaken there. The final AEOA core partner is the University of Dundee in Scotland, who have worked closely with SARI to progress and develop Earth observation and data access tools. Finally, by way of introduction, here is an overview of the key milestones of AEOA since its inception at the workshop organized in 2018. This was followed by a group of Chilean scientists and JNCC visiting the Falkland Islands, funded by the Foreign and Commonwealth Office and hosted by SARI and the Falkland Island government, where the first AEOA symposium was held. Since then, a number of collaborative Earth observation research projects have been undertaken, some of which will be presented today. This year, we have also looked to expand our partnership and invited some new organizations to join the Alliance. And of course, we are now hosting our second Science Symposium today. So just to give you a brief introduction to the program, which you all should have when you registered. We will start off with Dr. Fabio Labra, who is going to give us an overview of the Bahia LOMAS project. We'll then be followed by Dr. Guo Jones from JNCC, who will give us an overview of fire risk mapping in the Falkland Islands. And then we have Dr. Steffi Carter from SARI and Dr. Sergio Radic from University of Magallanes talking about soil mapping in the Falkland Islands. And we'll wrap up in an hour with some closing remarks from Dr. Jones. There'll be opportunities to ask questions at the end of each talk and at the end of the program if time permits. However, please do feel free to type your questions and comments in the chat, and no doubt the speakers will be able to respond after their talks if there isn't time to ask the questions verbally. So without further ado, I'd like to introduce our first speaker, Dr. Fabio Labra. Dr. Labra is a full professor of the Faculty of Sciences at the University of Santo Tomas in Chile. He's an ecologist who specializes in statistical modeling and analysis of ecological systems, including remote sensing and Earth observation modeling. He is the principal researcher at the Center for Research and Innovation for Climate Change, and his current area of research includes the application of remote sensing and species distribution modeling to solve conservation and management challenges in social ecological systems. Fabio, welcome, and over to you.
Thank you very much. Good morning, everyone. I will try to share my screen so that we can begin. Is it okay, Tara?
Yes.
Okay, it should be full screen now, right?
Yes, it's in presentation mode and full screen, Fabio.
Okay, thank you very much. Well, good morning, everyone. Good afternoon if you're in a different time zone. Thank you very much for coming to join us today. Today, I am going to be talking to you about a first experience we carried out within AEOA. It is this project using Earth observation to determine the distribution of suitable habitat for migratory shorebirds using a RAMSAR site at Bahia LOMAS as a case study. Okay, this was a study where we were a large team working in different parts of the world, Dr. Paula Lightful, Dr. Ward Jones, Dr. Megan Tierney, and myself. So a bit of context, we are working with a RAMSAR site that is found in Tierra del Fuego. It is Bahia Lomas RAMSAR site. It's a relatively large tidal flat found in southern Chile on Tierra del Fuego Island. And this wetland is a key wintering site for many migratory and wading birds, specifically the red-knot Calidris canutus, which has suffered a severe global population decline, most likely due to poor food supply at their wintering sites. So in this context, one of the important challenges to better manage and carry out conservation efforts for this RAMSAR site is to have information on the distribution of key habitats and prey species. Okay, so this project was put together within the framework of AEOA, and the key insight was to try and build a proof of concept to whether or not we could leverage Earth observation data to solve some of these problems. So the project goals were to create baseline habitat suitability models for the site using very high resolution commercial satellite imagery. Also to discover how data from Sentinel missions can be used to identify the low and high tide margin, which were an important metric because they define the area in the wetland that can be used by the migratory birds to feed. And also, finally, to develop some recommendations on how to scale up the work to other wetland sites, whether across Chile or beyond Chile, hopefully to aid efforts in monitoring other suitable areas for migratory birds that stop over on the West Atlantic flyway. So the habitat suitability models, they were built focusing on using remote sensing Earth observation data that were generated by 3 satellite missions. Okay, we worked with Landsat 8, Sentinel-2, and the project acquired a set of high-resolution World View 2 images. Now, those remote sensing images were used together with historical data where we had geolocated points for presences of the target species. Okay, I'm showing here 2 maps where we can see 2 sampling campaigns on 2009 and 2012, and the symbols represent the abundance of very small clam, Darina solenoides. Now, for this proof of concept, what we did was use this remote sensing information and historic location data together with relatively standard software, Maxent software, to fit the distribution models and plot the suitable habitat that's expected for different prey and habitat elements for these migratory shorebirds. So this is a very brief outline of the workflow. We need information on the intertidal habitat extent. We need the remote sensing satellite image, and we need the species presence data, okay? And we have to process them and use the machine learning algorithm to generate a map. Now, one important product of this project was to create some estimate of intertidal habitat extent, okay? This is a satellite view of Bahia Lomas Bay on the northern part of Tierra del Fuego. You can see the extensive flatland, and we needed to know what was the extent of the tidal or the intertidal area. We need to know how high and how low are the tides. This is necessary because those are the areas where shorebirds will be able to feed. It will be also important to validate the shore boundary of the RAMSAR site, which is the starting estimate is what's shown in the red line, and it may be relevant to monitor changes either due to seismic movement or sea level rise. So in this project, the team investigated whether we could use Sentinel-2 imagery to map the intertidal extent at Bahia Lomas. One core contribution of this project was that JNCC leveraged their skills and knowledge to provide analysis-ready data from Sentinel-2, this is an example, okay? Now, this is usually supplied as this imagery usually comes as a grid of tiles, and Bahia Lomas is covered by 2 tiles of the set, and acquisition is roughly around 1400 UCT, okay? This is an example of 2 images, and the project was able to build a catalog of high resolution or high frequencies images, okay, across all the visit times that we had. You must bear in mind that Bahia Lomas usually has a very cloudy environment, so it's not possible to have every single image with data. This information was used together with Coast X-ray. This is an approach for mapping the intertidal extent in near real time, and it's used by, it was developed by the Scottish Government's Dynamic Coast Project, okay? So through the networks of the AEOA partnership, we were able to reach out to the Dynamic Coast team, who kindly supported JNCC by trialing this tool with the Sentinel-2 data for Bahia Lomas. Very briefly, we take the data, not we, but the Dynamic Coast team processes to take the data, create a hexagonal grid, build a stack of cloud-free Sentinel-2 images, and calculate the normalized difference water index, which is shown in the formula there, and then apply a classification rule. This allows us to build a raster of water occurrence. Now, intertidal areas are expected to be those with the least water occurrence in the raster. This is a view of the app that was developed, and this is basically the final output that we get from the analysis. You will see areas that are classified depending on the percentage of water. Now, you will see that there are areas inland that have presence of water because you have either rain or water storage on the mainland. So we have some misclassification. So manual processing is required, and we used this 97.5 and 5% percentile in order to better estimate intertidal area. The left hand shows the vector map extracted from this process, and the right hand shows the manually processed vector file. So we get a pretty good image of what is the available area over the time period that we studied, which is basically 2016 onwards 2019. So we have analysis ready data. We have the water occurrence raster, which gives us the intertidal extent area. and we have species presence data. So we proceeded to build and fit the habitat suitability raster maps. This is an example of the output. Basically, the goodness of fit was relatively high. You can see in this graph for different resolutions or scales. On the left, you have WorldView 2 data, followed by Sentinel-2, and then you have Landsat 8, and the response variable is the area under the curve statistic. So pretty good fit in every single case, both in the training and test sets. These are the core objectives of our study. We have the clam, Darina solenoides. We have all polychaete worms, which both Darina and polychaete worms are prey targets for wading birds. And you have the sea asparagus, Sarcoconia magellanica, which provides resting habitat for the wading birds. And this is just to show you what the resulting maps look like. We have two projections on the February 2020 and August 2019. And on the top, we have Landsat 8. At the bottom, we have Sentinel-2. And warmer colors or redder colors show higher habitat suitability estimated by the MAGSENT procedure. That was for Darina. This was for polychaete worms. And this is for Sarcoconia magellanica. You will notice that in some cases we have some false positives, particularly towards the end of the intertidal habitat area. And we can use these data to estimate the shoreline distribution of these prey and habitat. And the project impact was basically to generate a baseline, which is being used by LOMAS Research Center as part of the inputs to update the RAMSAR site management plan. Specifically for the modeled habitat distribution for Darina solenoides, polychaete worms, and Sarcoconia magellanica provide a first estimate of the distribution area, okay? In addition to that, the project contributed another set of results. In addition to the analysis-ready data, the intertidal extent, and the habitat suitability, it also provided us with a set of Sentinel-1 radar images, which are analysis-ready data. It also provided a set of analysis-ready water and vegetation indices. So this is a lot of information generated by a single project. So what are the future research priorities? We need to keep on investigating the distribution pattern. We should move on to estimate both Darina and polychaete biomass and do standard stock assessment building on this work. We should expand their observation to include drone images to better geolocate and monitor Sarcoconia magellanica patches. Further sampling should also include this phenology of these plants, and we should explore other modeling approaches. So this will give us a better view of what these birds are facing. We should also expand the modeling to other areas. This is a small inlet, a little bit north of Bahia Lomas, and we can see that we can also carry out the modeling in those areas which are used by the shorebirds. Regarding the intertidal extent mapping, we should cross this information with local tidal data from Punta Arenas. We should be thinking of including Sentinel-1 radar data to improve mapping of water occurrence. And we should explore the use of different Sentinel-2 indices, okay? Now, this should eventually allow us to scale, and some recommendations, we should be able to think of developing a ready-to-use module based on the Coast X-ray experience and pilot that in other nearby intertidal areas such as Buque Quemado, which is the one I showed you, or San Sebastián in Argentina. We should consider to develop and present a research grant to use the radar data to do this and combine the information with NDYI information. So I want to finish by acknowledging the input of a lot of people. starting with the dynamic coast team, particularly the lead, James Feet and Alistair Rennie, for all the outputs and their kind contribution. Also, the UK Government Department for Environment, Food and Rural Affairs, who funded this collaborative project. University of Santo Tomas and JNCC were the main partners in the project. AEOA, as such, was key in enabling this project by hosting it and fostering collaboration opportunities. The field sampling has been funded over several years by several institutions, including Chile's Environment Ministry, oil company ENAP, our university, and Manomet. And the sampling, which is paramount importance for being able to do this work, was made possible by the collaboration and help in the fieldwork and the lab by several people: Ricardo Matus, Alejandra Ponce, Olivia Blanc, Gabriela Gonzalez, Antonio Larrea, Melissa Villagran, among many others, all of whom were led by Carmen Espos, who is the director of Centro Bahía Lomas. Okay, that's what I wanted to share with you. Thank you very much. There we are.
Excellent. Thank you, Fabio. Such a interesting, productive project with some really useful research outcomes and then multiple opportunities for the future. So thank you so much for sharing. There is a question from the audience. So it's from Steffi in the Falklands. If Bahía Lomas is normally very cloudy and cloud-free imagery is difficult to obtain, why was Sentinel-2 imagery used in the project and not Sentinel-1?
Yes, that's an excellent question. Well, the main thing was that our prior experience had been, okay, let me start by acknowledging, is it extremely difficult to obtain cloud-free imagery for Tierra del Fuego? They're very infrequent. It's very hard. We did some similar studies back in 2011. And we had, using the Landsat catalog, we had a delay or a lag of about 5 years. So the earliest image we had was in the middle of the 200. Okay. Now, the reason why we focused on spectral imagery is that we wanted to do habitat modeling, and it's not being used with radar data. So basically, radar data does not allow us to easily discriminate different materials on the Earth's surface. Okay, so we can infer something regarding, for example, a forest versus grassland, but we cannot infer intertidal habitat which is covered in rock, or is covered in sand, or in silt, or it has plants. So we can do that in a better way using spectral imagery, which is why we focused on Sentinel-2. So basically what we did was go all in. JNCC and using the funding from DEFRA acquired Worldview 2 imagery, which we also use, which was multispectral imagery. We use Sentinel-2 and we use a Landsat 8. So these results should be considered more. They should not be considered a dynamic modeling, but rather a baseline average model for a, I would say, decadal period. So we should actually average everything. We should average all the output that we have, because we have a single set of presence data which span from 2009 to 2019. And we have a stack of imagery at different resolution, which span also from 2015 onwards to 2019.
Brilliant. Thank you so much. Thanks, Fabio. I think that's all the questions we'll take at the moment, just in the interest of time. Gua, if you are okay to get your screen ready, and I will thank Fabio and now introduce our next speaker, who is Dr. Gua Jones. Dr. Jones is an Earth observation specialist for the Joint Nature Conservation Committee with 10 years experience in remote sensing and GIS for environmental applications. Currently, she is working to remove barriers for uptake of remote sensing and is an active member of the DEFRA Earth Observation Center of Excellence. As a data scientist, she has set up operational standards for Earth observation data in the UK and is the technical lead on the development of a UK-wide standard for Sentinel-1 and Sentinel-1 analysis-ready data products. Gua also leads on the use of Earth observation in the UK's overseas territories to map and monitor environmental change, and is a founding member of the Austral Earth Observation Alliance. She's leading on modeling the impacts of disasters on natural capital and the economy, and to identify sources of natural resilience and opportunities for nature-based solutions to tackle climate change using Earth observation. Gua has also delivered numerous training courses in the UK and internationally in the use and analysis of Earth observation data. Gua, over to you.
Thanks, Tara. Can you see my screen?
I can, yes, it's full screen and all good to go.
Brilliant. Thank you for that introduction. I think it might also be worth a quick explanation of JNCC, just in case that if there's someone online who's not very familiar with this. So we are a public body, so we are part of UK government, and we advise the UK government and devolved administrations on UK-wide and international nature conservation. But we're an impartial scientific authority at the end of the day, and we do provide advice only on practical, policy relevant and evidence-based solutions, primarily to support decision making. So that's JNCC before I get started. So this presentation is a presentation of a project concept. So we haven't actually started this project yet, but the plan is advanced enough for us to present the idea. And the project concept is all about looking at how we might go about mapping fire risk in the Falklands, but also a little bit about how we might manage that risk in areas where the risk is high. So a little bit of background to the project. We know that Earth observation data and tools can be valuable in monitoring and management of wildfires, and we did first discuss this idea at the Falklands Chile Science Symposium, which Tara mentioned, that occurred back in 2019. And then JNCC and SARI kind of came together and started discussing how we might go about dealing with this issue in the Falklands, and we did that by going to speak to probably one of the main stakeholders and customers of any output of this project, which was the Directorate of Emergency Services and Island Security in the Falklands, and they were mostly interested about using Earth observation data. But also outputs created from Earth observation data, such as habitat maps, the soil map that Steffi's going to be talking about after my talk, and how they could use those outputs as well as just generic Earth observation data in their field of emergency services. Now, this is particularly around enhancing capability for planning real-time responses through simply just knowing habitat type and extent, the location of the nearest water sources and the depth of peat, as well as exploring remote sensing tools for future fire risk modelling and management, and potentially other emergencies too. So it has been highlighted that the potential for this work and similar concepts have been undertaken in the UK. I will briefly mention a couple of those later on, but given the landscape in the Falklands, there's a high potential that whatever we do or come up with in the Falklands would be highly relevant to areas in South America as well. So why are there concerns about fire? The Falklands traditionally do not have habitats that have adapted well to fire, so fire is generally a destructive thing. And one of the biggest issues in the Falklands is that the islands are vast and large parts of the islands are isolated, which makes it difficult for emergency responders to get to fires when they happen. The images you're seeing on the slides, flicking through Sentinel-2 images of the island Grand Jason, which experienced a fire in January this year. So it's the dark brown patch on the bottom left hand corner of the image, and you can see the fire expanding as time progresses through the images. Although the risk to people can be perceived as relatively low, the Falkland Islands are a wildlife haven to many protected species, including seabirds such as albatross, and fires like these can devastate nests, which can have a long-lasting impact on bird populations. Also, if these fires get into the peat, they can burn for weeks, causing irreparable damage. And once the peat is gone, it's very, very difficult, if not impossible, to restore, which means that the Falkland Islands are losing valuable resource. So it's important to try and manage these fires if we can. So one of the approaches that it was a lot of in JNCC, which we apply in our projects, and is worth explaining here, is how do we actually integrate Earth observation into these sorts of solutions, and how can Earth observation make a difference? So our approach at JNCC is to use Earth observation as an implementation tool. And we can adapt this approach to numerous different types of scenarios. So one of the biggest advantages of Earth observation data is it provides frequent, high-resolution data, and therefore can provide an evidence space for our landscapes and seascapes. But it's best used if it's coupled with other data sets and local knowledge that allows us to turn the terabytes of data that we get from space each day into application-specific information. And then we can use the power of modelling, machine learning, a whole host of different methods to really help us inform on impacts of decisions, allow us to build tools and solutions that really will make a difference in how people at all levels can make decisions, from the highest level of government to people on the ground. And talking of people on the ground, JNCC normally works with partners and collaborates with others to ensure community engagement, and that also gives the potential users of any solutions that we bring up a sense of ownership, that they understand how the solution has come about and how they might actually get to use that in the future. So we've done a couple of fire risk mapping projects at JNCC in the past, slightly different context from both of them, but they're ultimately looking at the longer term vision and trying to understand how we can act to reduce fire risk with whatever management techniques and tools that are available to the people on the ground. So one of these projects was in Chile, looking at viticulture and the role of fire risk there. And the other project that we've just about finished is in the Brecon Beacons in Wales, looking at opportunities to manage the fire risk on the commons by using a suite of different land management types. So there are several approaches that we could use in the Falklands, and they can both be adapted depending on what might work best in that specific landscape. And that also includes, creating several different types of risk outputs. You can just create an overall burn risk, or you can, specifically look at how you might avoid burning altogether, or once a fire has started, how that's going to spread. But the role of Earth observation in all of this is key. So you will notice that a lot of the inputs into these methodologies are based on Earth observation data and products, including elevation, habitat maps, vegetation indices, and also data on previous burnt areas, which we've used the MODIS data in the past. So we're also a big fan of using already existing models and applying them innovatively at JNCC. So you might be surprised to see a species distribution model being applied here, but the concept is pretty simple. So a species distribution model works on input data about the landscape and presence data, and then it spits up the probability of that species being present. Well, in this instance, it works in a very similar way. We give it a bit of input data based on the landscape and give it presence of past fires, and then the model predicts the probability of fires happening in those areas again. So, you know, even though we call it what it is, we're using these models and these methods innovatively to get to a solution. So you've heard me talk about land management a couple of times now, and I think the key here is understanding how we might be able to reduce fire risk, if at all possible, or, you know, understand what the fire risk is and how we manage our landscapes and how that might impact fire risk. So these are the sort of activities that happen in the Falklands that might have an impact, and might change fire risk. And one of the biggest issues with wildfire is fuel, especially in places that don't have habitats that have adapted to fire, like the Falklands. And it is common to use fire against fire, so prescribed burning, to reduce the fuel load and therefore reduce the risk if a wildfire occurs, which we know happens quite frequently in the Falklands, caused by lightning, etc. But there are other activities in the Falkland Islands that might have an impact, potentially to lower that risk. We're not sure if that is the case yet, but that's what this project would look like. But they're not activities specifically carried out to reduce fire risk. They're normal things that happen in the Falklands every day, such as grazing. There, of course, needs to be a balance here. So, we can't graze everything to death, because there'll be nothing left. So it needs to be a balance between maintaining healthy ecosystems and being sustainable. And this sort of project can be expanded in the future to consider those other sorts of services from the land. So I thought I might show you what a tool that this project is inevitably looking to create might look like. So this is the tool that we've currently developed in the Brecon Beacons. The idea is that you can select an area by habitat, zoom in, pick any specific characteristic in the landscape, and then select a type of land management and see how that impacts the fire risk. So the layer that you're seeing here is the fire risk in a specific area in the Brecon Beacons, where dark red is the risk is very, very high. Unfortunately, in Wales, there's a culture around starting fires by arson, and a lot of these areas in the valleys here, they're close to populations, which is why the risk in the south is higher than in the north, because there's less people living there. But that's a social element into this project that it's very, very difficult to control. But, if you apply certain types of grazing or manage the fuel load by carrying out, controlled burning in these areas, then this tool can help you understand how the risk then decreases. So it helps you understand what sort of management activities you can apply to reduce the risk, and in which areas that's going to make an impact. So it's a tool to help people make decisions based on what might be the best outcome or the best solution going forward, specifically to fire risk. And tools like these can be designed, ultimately with the stakeholders, so they can be tailored to suit the requirements of the customer. And we can add things like sources of water, which is something that the Falkland Islands security emergency responders would be interested in. And finally, the next steps of this project is to get it going, and we are currently in discussions with Swansea University to try and get a research student to carry out the technical elements of the work, while we will also be contributing by continuing the engagement with the stakeholders to better understand their needs and how this work could make the most impact. And I'm going to leave it there for today, so thank you for listening.
Thank you very much, Agua. There are a few questions, comments in the chat, but I am actually not going to open the floor. If you're okay to pick any of them up in
I can answer in the chat, yeah.
Yeah, please, just because in the interest of time, we're overrunning a little bit. If people want to stay online afterwards, then we can probably follow up maybe when we officially close the symposium. But thank you very much, Gua. Really, yeah, interesting and useful tools, and good to see the different application of concepts across sectors. So really interesting. I'd now like to invite our next two speakers to prepare for their presentation. So while you're preparing, I will introduce Dr. Steffi Carter, who has gained a PhD from Aberystwyth in 2018, which focused on the impact of different drain blocking techniques on gas flux vegetation and invertebrates in an upland blanket peat. Steffi's passion for the natural environment also enabled her to acquire a wide range of ecological knowledge. And she arrived to join us at SARI on the Falkland Islands in August 2018 to lead a 2-year Darwin Plus soil mapping project, which she'll speak about today, which produced a range of soil maps for the Falkland Islands. Steffi is now managing a 2-year Darwin Plus wetlands project, which aims to create a baseline for wetland habitats across the Falkland Islands, and at the end will inform local government on long-term monitoring strategies. The talk is a joint talk, so by Steffi and Sergio. So I'll also introduce here Dr. Sergio Radic from the University of Magallanes, who is currently an associate professor at UMAG and holds the position of Director of Research. He carries out teaching activities in the subjects of soil fertility, grassland management, and forage, and he is a thesis advisor to undergraduate and graduate students. He has developed areas of research such as soil-plant relationships and the use of remote sensing for grassland management, publishing different articles in national and international conferences, scientific journals, etc. In the area of soil-plant relations, he has developed studies on aluminium toxicity in forage plants, nitrogen fixation in subantarctic environments, evaluation of native plants for their introduction in acid soils, and evaluations of soil fertility in the region. In remote sensing, he has also worked on the development of a platform for dynamic monitoring of the region's grasslands and on the use of remote sensing as a farming support tool. So welcome, Steffi and Sergio. And Steffi, I'll hand the floor over to you. I can confirm that we can see the presentation mode of the presentation.
Thank you. Okay, can you hear me now?
Yes, we can hear you now.
Excellent. Thank you very much for that, Tara. So I will talk about the the soil method project that ran from 2018 and finished last year in October 2020, and I will try to focus about the Earth observation aspect of the project in particular. The project was funded by the Darwin Initiative through UK government, and there were lots of different project partners involved, which is the nice thing about these Darwin projects. It brings together lots of people with different expertise. We had the James Hutton Institute in Aberdeen involved. They ran the soil mapping, the digital modeling side of things. The Falkland Island Trust was involved. The Natural History Museum in London looked at the microbiology of the soils here in the Falklands. The Falkland Island government was involved. We had lots of support from the Department of Agriculture there. The UK Centre for Ecology and Hydrology was involved through Chris Evans, who is in the audience here today. And also the University de Magallanes, so that's where Sergio comes from. So I will first talk about the project itself and the different steps we took in order to get all these maps, and then Sergio will talk a bit more about sort of the practical implication of these. So first of all, when we started out the project in 2018, this is sort of what we were faced with. that farming in the Falklands is quite different in many places across the globe, where the farms are really, really big here. On average, about 140 square kilometers. The largest one is 1,180 square kilometers, which is twice the size of Santiago, for instance. Which also means that the individual paddocks, the subsections of the farms are big, and sheep have got large areas to roam around. So grazing is not really equally distributed across the land. So because of the way that sheep graze, they like to nibble at what they prefer. So which could mean that certain areas get higher grazing pressure than other areas. And also, if you look at the graph here, you can see that historically we had quite a lot of high numbers of sheep in the Falklands for quite a long period of time, and only sort of around between 2000 and 2005 the numbers started dropping down. So the grazing pressure is taken off the land a bit now, but that meant that in certain areas this has led to overgrazing, which has led to erosion issues and so on. And also looking at the climate change predictions, and I think that was one of the questions from Ed Rowe just now. What are the predictions for the Falklands? So we think that temperatures will be warming up by sort of roughly 2 degrees on average over the next 100 years or so. We expect, so we've seen over the last 100 years or so that winds are getting stronger, gales are getting stronger and become more frequent. It's difficult to predict this, but it is very likely that this may increase. And we already have a period in the spring and summer where you get a certain soil moisture deficit. So basically that means that the moisture that you've got in the soil evaporates, and it comes out, from the plants as well through photosynthesis, so that the water that you lose through these processes is more than you actually get in from the rain, and it's already about sort of 150 days a year over the spring and summer, and it is thought that that period will increase even more. So basically, the prediction is that the soils will become drier, and so we're looking at sort of more erosion issues, carbon loss and so on. And also the other thing is, if temperatures increase, warmer temperatures can hold more water. So possibly, as we don't know what the rainfall will be doing, but the assumption is that sort of rainfalls will be stronger and shorter, which of course means that less of it will actually be able to be absorbed by the soil. So the idea was, for the project, we needed to create a national soil map. Basically, we had to fill in lots of gaps and baselines. So to determine things that we didn't know. For example, there was no national soil map in the Falklands. We had one which was quite crude, quite broad, based on an interpretation of the geology. But land managers didn't have any tools to work on their land management. There was no idea of certain properties in the soils, how they're spread across the Falklands in terms of sort of fertility of the soil and so on. And we had no baseline for the extent of peatlands, carbon stock and erosion. So the estimates for what the peatland extent in the Falklands are well sort of between 25% of the areas covered in peatlands to 95% or something like this. So there were lots and lots of unknowns. We were trying to fill these gaps with a project. So the way we went about this is with digital soil modeling, just because we had 2 years to do this. So creating the soil map of England and Wales took about 30-40 years with dozens of people on the ground. So obviously we didn't have time for that. We had 2 years to do this. So we used digital soil modeling. That meant, and I will go and talk about that a bit more over the next few slides, but basically it meant there was one round of modeling to determine the fieldwork points where we had to go. Then we carried out the fieldwork, took some soil samples back into the lab with us, did lots of analysis there, and then all that information was fed back into the model. And the second round of modeling then produced these maps. So now I'd like to talk about the parameters that were included in the digital soil modeling. And this is where we get to the Earth observation side of things. There's no way we could have done this project without any Earth observation information. So one element that went in was the digital elevation model, which already existed before the project started. That came about from the shuttle radar topography mission, which collected imagery in 2000, I believe, and the idea of that project was to get digital elevation information from all across the globe. And from that digital elevation model, we had lots of information such as slope, aspect, curvature, flow, accumulation, and there's a long list of other parameters that you can get from this. We also used the broad scale habitat map, which was created by another project that SARI ran, another Darwin project, the Coastal Mapping Project. And they used satellite imagery themselves from Sentinel-2. And this broad scale habitat map created a map with lots of different habitat classes. And this is important, for instance, if you look at where you get certain types of vegetation, you might get certain types of soil and so on, and that information was fed in there. And we also used satellite imagery directly. That was one of the parameters that went into the model, and looked at the vegetation cover through NDVI values on the satellite imagery. And other parameters that went into the model were information that we already had, for example, a geology map, and the existing soil map, which is at the bottom of the screen here, which I mentioned briefly, which is the interpretation of the geology, and it's very, very broad. And as I mentioned before, the field descriptions, they were used for soil classification. So this is where we got the soil classes from, and then all that lab data gave us information about, for example, nitrogen, phosphate, magnesium, calcium, and so on. There's a long list of physical and chemical properties that we got from the lab data, and that went in the second round of modeling, and we've got all these maps. So I'll just talk you briefly through, just give you a few examples of the maps that we've got. So this is the soil class map, which is sort of the traditional soil class map. The classification was carried out through the World Reference Base of Soils, and this is where you get all your different soil classes from, and then you can. Oh, I just want to mention at the top right, I put a link in to the project WebGIS. So hopefully we put these presentations on a website somewhere. And if you want to look at any of these maps in detail, you can click on that link, and then you can explore these maps. And there's information, for example, about the different soil classes, what they mean, and all of the other properties as well. So we've got a map now for peat extent. So the first map up at the top gives you the layers with all the different peat depth, and from that one we can create a map of peat and no peat, and we use 40 centimeters as the cutoff. So basically, if you've got a map depth of 40 centimeters, you can classify that as a peatland. That's a very common sort of cutoff point, which is used globally. And from that, we can calculate a figure of what is actually peat in the Falklands, and our magic number is 37.8%. And if you compare that to the UK, actually, there's a lot of peat in the Falklands, so more than Northern Ireland and Wales combined. And as many of you know, there's lots of peat in Northern Ireland and Wales as well. So there's a significant amount down here, which is, of global importance. We've got a baseline now for erosion. So if any of that changes in the future, we can go back to our original map here. So if you just look at the map very broadly on the left, you can't actually see it very well. But if you zoom in into certain areas, like I did on the right-hand side, and you compare that to the satellite map, you can actually see how accurately that maps erosion. And looking at the next slide is another example is erosion risk, which we categorized into low, medium, and high. So as you would expect, in sort of mountainous areas and steep slopey areas, you get a high risk of erosion. And these are just examples of the different chemical and physical soil properties. And all of this you can explore on the WebGIS and zoom into the areas that you're interested in. The resolution is 30 meters per pixel, which sort of from a farming point of view is actually quite detailed and really, really useful for the landowners. And now I'd like to hand over to Sergio, just to talk a bit more about the practical implication of this and for other areas as well. Sergio, are you there?
Hello.
Sergio, we can hear you. We can hear you well.
Okay. Good morning, everyone. Thank you very much for this invitation. In relation with the project, I want to support all these results because are the baseline for a good land use planning, and with this generate a strategic planning for farming, environmental management, or others. The value of the information from the soil map is useful for global information for forecasts related with environmental matter and public policy. For another part, always I'm thinking the application of any research in the farm. And one important thing is to know the different perspective of the vegetal communities, as Steffi showed before. We can know how many hectares there are in each paddock and understand with this the value of each paddock in relation with others. Also, it's important to know the key points in the farm, like the water points, gates, corral, others. And for example, in the figure at the right side is a map from a farm in Tierra del Fuego. This farm has around 2,400 hectares and is divided in 9 paddocks. The map has a different colors. In each color represents different vegetal communities. For example, the paddock number 9 at the bottom in the right side has 490 hectares roughly, and shows 3 different colors. Red one represents Diddle-dee, green is the valley, and yellow is a tussock of native fescue. Similar idea with the whitegrass in Falkland. In this case, we know the hectares of each vegetal communities, and with this information are possible to estimate the current capacity in a best way. Another important value of this information is the farm soil characteristics. Next slide, please. Next slide, please.
Steffi, I think, are you managing the slide? From
Sorry,
that?
I'm trying. For some reason, it's not doing
Okay.
it. Just bear with me. Sorry about that.
No problem.
I think something's frozen here. Oh, okay, it did it. Sorry about that.
Okay, no problem. It's moved now. Sergio, is that the right slide?
Yeah, it's okay now.
Okay, brilliant.
In this slide, this is a lab experiment with Falkland soils. In the graph A, it's possible to know the relation between pH and aluminium. And the curve has different point dispersion, but we don't know why is this dispersion. But in the graph B, we have the same point, but with different colors, depending of the organic matter in each side. And now it's possible to understand better this data dispersion. As Steffi showed before, the project collects different soil parameters. And with this, it's better to understand the different relationship in the soils. And this is the beginning for the future calculate. For example, estimate the carbonate calcium doses to improve the soil acidity and raising the pH, for example. All this information is possible to see in the Google Press of May and June 2020. Next slide, please. The final slide is to show you a new idea that you can work in Falklands with remote sensing and map job and the earth, any job with the Earth observation. The ecosystem service, the specific point in the carbon stock. Into the books called Grassland from David Brisky in 2017, show the relation of dry matter production of forage and the carbon above ground biomass for different grazing management. And it's possible to see a better carbon stock when the management is with a moderated grazing in comparison with grazing exclusion or intensive grazing. This is important because it's possible to maintain the equilibrium in the farm without overgrazing for one side, and another try to sell carbon credit. But for this, it's important to follow the project about Earth observation and generation of map and all this kind of job. Thank you very much for your attention.
Thank you very much, Sergio and Steffi. Really interesting, another really interesting project and some wonderful research outputs. So we are overrunning for time a little. What I will do is ask Gua to say her closing remarks so we can close the program officially. If anybody wants to follow up on any discussions and is free afterwards, Ed, I know you had mentioned that it would be useful if you are free and available. Most of the speakers can stay on for a little bit longer, so they'll stay around, and if anybody wants to stay online to ask any follow-up questions, then feel free to do so. But well, if you can give us your closing remarks, and then anybody who does need to leave also can do so. Thanks very much.
Thanks, Tara. I'll keep it short. I just want to thank everybody for all of their efforts in AEOA, I think, because there's been a lot of people involved in the 3 projects that we've introduced and presented today from all over the world. And Earth observation is the key thing that's bringing us all together in essence. So I'm quite impressed by the breadth of projects that we can help innovatively help with Earth observation, from fires to soil to helping understand the movement of migratory birds. That that's the 3 completely different fields in one sentence. And I think AEOA's work in fostering those collaborations is really to be commended. And I think Earth observation is a beast to handle. There's a lot of challenges still when it comes to use of Earth observation, from local scales to global scales. But I think through work like AEOA has carried out, then that's going to make a massive difference, because it's going to enable us to learn from each other, knowing that we've got similar problems and similar goals to achieve. So I just want to thank the organisers once more, and Bree specifically, and also I'd like to thank all of you for coming to listening to all of the interesting projects today. So that's my closing remarks, Tara. Hopefully we'll have more of these projects to present in the near future.
Brilliant. Thanks, Gua. And just to reiterate, thank you to everybody for joining. So the event is officially closed. If you are free, Ed, if anybody wanted to ask any questions and stay back, feel free to do so. But if you need to leave, of course, feel free to do so as well. Ed, I see your message, you need to leave, but if you wanted to ask something, then we can open the floor to you.
I think he's just said in the chat that he has to leave, Tara.
Yeah, I just saw him switch his video on in case he wanted to say anything. So I guess any questions from the floor? Is there anything you wanted to pick up from the chat, Gua or Fabio, to kind of make a comment on?
I think I've answered my questions in the chat, but they're fairly complicated. So probably best if people just read the response than extend the time here now, Tara, since we are overrunning. I think that's what I would say.
Okay. I think we have one new message.
Yeah, I just wanted to thank Sari for organizing the symposium, and once again thank all our colleagues in AEOA, and I would just like to stress that what we have done would not have been possible or would have been extremely difficult to achieve outside of AEOA. So the speed with which we could do the networking and, you know, pinpoint ideas and, you know, put them on the wall, discuss them, and then everybody contributing on potential ways to make it come about. That would have been very difficult without the workshop, without the meetings, and without the alliance. So once again, I would like to thank everybody involved in the common effort that is AEOA.
Okay, brilliant. Thank you so much.